Graph showing effects of steady-state exercise. Effects of steady-state exercise on heart rate for Josh, Summer and Max. This graph shows the effects of exercise on heart rate for Josh, Max and Summer, which are all generally increasing. They start at a low resting heart rate of about 75 beats per minute for the pre-exercise and up to 2 minutes. The heart rate increase is minimal. As the duration of exercise increases from 2 minutes to 10 minutes, it shows all three heart rates increasing steadily. Josh's heart rate is shallower and continues to steadily increase until 18 minutes. The heart rates generally increase up until 6 to 8 minutes, or an average of 25 to 80 beats per minute. Then at 8 minutes for Summer and Max, it starts to plateau due to the heart rate staying at a steady rate for continuous exercise at 70 to 80% of their maximal heart rate. When looking at the data, we can see that Josh's heart rate at 3 to 2 minutes is at 105 beats per minute, which is 15 beats higher than the average heart rate. This is an anomaly, and we should disregard this piece of data. The reason behind this data may be that they had a different warm-up routine, perhaps with Josh not having a rest, while Max and Summer had a 1-minute rest before beginning the exercise. When observing the normative data, we can see an increase at 2 to 4 minutes, but then levels plateau around 6 to 20 minutes, as they will be working at 70 to 80% of their heart rate, which is the level of steady-state exercise. At the end of the exercise, we can see a slight decrease due to the heart rate returning to their resting heart rate. When comparing these pieces of data to the normative data, we can see that Max and Summer had an average and increase at the beginning of the exercise, but then plateaus due to meeting the demands of the exercise. However, Josh M has a increase, then starts to increase steadily, which is significantly different results to the normative data, and may have to consider retesting. Effects of steady-state exercise on breathing rate for Max, Josh and Summer. These graphs show the breathing rate, the number of breaths per minute for Josh, Max and Summer during steady-state exercise. All clients had an increase in breathing rate as they performed exercise. Summer had a breathing rate of 17 at start, and it increased gradually until it reached 34 at 14 minutes. It then dipped at 16 minutes, which may have been an error in data, and at 18 minutes it gradually declined back to 28 in the post-exercise period. Josh had a pre-breathing rate of 26. It rose steadily until 4 minutes, then it dipped and gradually increased until it reached 35 at 18 minutes, where it fell back down to a resting heart rate. Resting rates post-exercise. Max's data should be considered as an anomaly. Max is working at a higher intensity due to a technical error in the device used to measure his heart rate, reading 90 when actually it was nearly 195, meaning that Max was asked to exercise harder and so had to breathe at a higher level to maintain the demands of the exercise. Josh and Summer data shows an increase of about 10% at 4 minutes as the intensity of the exercise started to increase in order to reach the 70 to 80% of their maximal heart rate. All the participants plateaued at around 6 minutes. The normative data has a slight increase at the beginning of the exercise due to the intensity increasing and the level of work was getting harder. At 70 to 80% of his maximal heart rate, to supply oxygen to the demands of the exercise, then the breathing rate would plateau at around 10 to 18 minutes due to meeting the demands of the steady-state exercise. Then this breathing rate would decrease about 10 to 15 breaths due to stopping the exercise and his breathing rate. Effects of steady-state exercise on oxygen saturation. This graph shows the oxygen saturation, the measure of oxygen in the blood. For Josh and Max and Summer, when working at steady-state exercise, the data for Summer and Josh has to be discounted as an anomaly. Max data shows a pre-level of 98, which falls to 6 minutes at a level of 91 and then increases again until 14 minutes when it reaches 97. Again before falling away again until 18 minutes at 91. It then rises and plateaus at 98 to 99 post-exercise, showing that it has a zigzag pattern. As for Josh and Summer, their data was incomplete, so can't get a true result. But of the look of it plateaus the whole way through the results. The normative data has a steepening increase, then it has a slower increase and slowly starts to plateau, then starts to decrease at 8 minutes when he starts the exercise. The normative data is very different to the results he got, as Max's only increased by 0.2, then decreased about 10%, then his then plateaued, had a plateau effect. There is an anomaly in the results, as one of Max's results is 83, which is a very big difference, which could be because the testers didn't read the results right, and then this would mean that they didn't record it which has less of a difference. Lactate levels during steady-state exercise. This graph shows the lactate levels, the amount of lactic acid in the blood. During steady-state exercise, at the beginning, only 2 out of the 3 clients had sharp increase in lactate levels. When they started to perform exercise, they had an increase of about 14% due to having to work harder. When Max and Summer were doing more and exercise, the lactate level will continue to increase by 3% due to the performers starting to slow down, as they would be working at 70 to 80% of their maximal heart rate. Then, as they finished the exercise, their lactate would decrease as there is less blood being pumped around the body. The normative data has an increase when beginning the exercise, when after about 2 minutes it starts to plateau to about 12 minutes, which is then starts to decrease steadily due to the stopping the exercise and not working at 70 to 80% of their maximal heart rate. The normative data is similar to Max and Summer results. However, the normative data is steeper increasing and has a more constant plateau and a steadier decrease at the end of the intense exercise. And Josh's results, due to the miscalculation and technical difficulties, was very different to the normative data, as Josh's results only increased by 2%, which is very steady increase. ratings during steady state exercise. These graphs show the ratings for Josh Summer and Max when working at steady state exercise. The relative is improved. The rating is important as it tells testers how hard the performer feels he's working at. This would indicate how valid the exercise is. For example, if the performer said he is working at a rating of 16 but isn't showing any signs of struggling, then he might be lying and you would have to ask him again for a more accurate rating. If the performer is working aerobically, then the normal rating is from 12 to 15, as you don't want them to be going into oxygen debt by working anaerobically. The rating are also the normative data. The normative data has a big increase at the beginning of the exercise, and at about 6 minutes it starts to plateau. At about 14 to 16 minutes, then starts to decrease slightly due to the performer getting used to the exercise. This is different to our results, as our results increased by about 8, which is at 8 minutes. Then it automatically starts to decrease to post at low and steady rate. Effects of steady state exercise on blood pressure. This graph shows the effects of blood pressure for Josh, Max and Summer when working at a steady state exercise. What happens? The systolic and diastolic blood pressure phase, all Max and Summer's heart rate differentiate a lot. During the experiment, this is due to the systolic and diastolic blood pressure phase both increasing, which is shown by the slight increase in the graph. The normative data for the blood pressure at the beginning when a performer starts an exercise, there is an increase due to the intensity increasing and the heart rate getting faster. It will then reach about 60 to 80% of its heart rate, which will mean that the breathing rate will be constantly showing a plateau effect on the graph. Once the performer is slowing down to stop the exercise, and it starts to decrease slightly due to the performer working at a lower intensity. Max's diastolic phase decreases by about 30, which is different to the normative data, which says it would increase this. This could be due to not recording every 2 minutes, so you would need to do a retest to see if it would line up properly. However, Summer's results follow the normative data apart from 8 minutes to 12 minutes, where it looks like she was starting to fatigue. Max's systolic blood pressure has a decrease at the beginning, where it went down by 38. This could be due to the experiment method and will have to do further testing. Summer's systolic blood pressure stays with the normative data, however, there is a slight decrease from 146 to 143, then to 120. This could be due to Summer starting to fatigue. Josh's results was an anomaly due to the testers not recording properly, and I would also disregard Max's results and do further testing for them. CV system. Hypothesis. During steady-state exercise, the heart rate increased at the start of the exercise until it reached 60 to 80% of their maximal heart rate. It then starts to plateau as the performers reached their demand for exercise. Then, when the performers slowed and started to stop their heart rate, levels